got started on this study?
Okay, this particular project actually was out for a competition a couple of years ago, and a few well-known architects bid for job, and we actually helped and recommended the architects who are on board this project, Architect Circle, to win the job, as well as make that design is able to go for the tender, so the contractors can quote for the job. So initially we helped them to standardize some connections, and in terms of the scheme, we helped them to make some changes in terms of working in engineering aspects, and then that goes to the tender. So that's very preliminary design during that stage. Then of course, after the architects won the project, and then we tender for that project together with the contractors, and we won the job. And then we started working on the real design scheme. There are a number of challenges we faced during that construction period.
Okay. So right from the beginning though, timber, mass engineered timber was the decision that you would use the majority timber for the whole job.
Exactly. I mean, the whole point of this project is actually, it is required to use mass engineered timber for the majority of the components here. So as you see, the first level and the second level is all MET. Combination of glulam and CLT. And the basement you have other conventional materials such as concrete, steel, etc.
So if you took the whole project, what percentage of timber would be the material used? Would it be 80%?
Yeah, pretty much about 70% and above overall.
And is that about standard for jobs you do in Singapore?
In terms of the percentage of the timber you use, there is no standard, but a lot of developers and the designers, they would like to use timber as much as possible. Due to a number of reasons, of course. It looks beautiful, and it's also more sustainable material on earth. You could use it, it's productive. So due to those reasons, a lot of designers and the architects like to use that as much as possible for their projects.
So it's for the look as well as the structure, obviously.
Exactly.
So just tell me about the complexities of this particular job. What were the challenges?
Right, good question, because you may thinking it looks like a simple building, but it's not. The reason is very simple. You have 25 frames for this particular building. Each and every frame consists of 3 components: glulam columns and 1 glulam beam. They're all different. So you need to design each and every connection in a very specific manner, and each and every connection is different, and they are identical to each connection. So our engineers spend a lot of time fine-tuning the connection, yet to meet the architect design intention, because that's very important. We had to deliver what client required in terms of the aesthetic look, and we managed to make it happen. And not to mention, this is also the very first project in Singapore to use this highly efficient connection system called gyros, which are concealed connectors. We installed it in the factory in the Europe, delivered to Singapore, and installed it on site.
So just describe that system then. That involves using steel?
Yeah, exactly. It's involved the steel rods and very specific epoxy that's penetrated into timber and then delivered to site. So all you need to do is just put it together with the steel component and install it on site.
And is that for added strength to the project? What was the reason for that?
That's right. As you see, I mean, for example, these components are all look like you want to fold from one side. So you can imagine the forces you have here to restrain that force. So that's why we got to use that kind of technology, a special connection system for you to restrain that load and meet the loading requirement as per engineers' design.
So and obviously, you know, the timber that you ordered came from Europe. It was all specified in advance, the size, the shape, and everything else. So there were no problems from that side of it.
No issue, because when we work, of course, our engineers optimize the sizes due to a lot of concern, logistic, delivery, the site restrictions, length of the components, very important. Our engineers work around that, and that goes to manufacturer, and they produce the components in the Europe as a prefabricated component.
We really have some other challenges here at the moment.
Yeah, I mean, we had a lot of challenges.
The work site.
Yeah, and Ken, as you know, this is probably, I mean, we don't have any official information, but based on our research we have done so far, this is the most complex timber building across Asia, mainly due to the complexity of the structure and the design concern. So we're proud to say that we managed to deliver this kind of highly complex yet beautiful structure in Singapore for the owner People Association.
And was it because timber was specified did that make it more complex, or was that really a solution?
It's more to do with the complexity and the geometry itself, and adding together with the timber. It's all in actually. It's a combination of timber, the geometry, loading requirement, fire requirement. It up everything together, made this building very complex. But it's a good project. We work all together to make it happen.
Now, I get the impression it's very open. Is this what it will stay like this? There'll be plenty of breeze through? And
there will be. There are certain areas they will have external cladding. Certain areas will be exposed to weather, but not completely exposed to rain. So yeah, they have different rooms. There are some aircon rooms. There are certain areas for aircon. There are some areas for them to park the canoe boats. A lot of activities. It's a public accessible place built for mainly for water sports adventures.
So you're pleased you've got to this stage. It's pretty much complete from your side of it. So you've got there. There have been the challenges, but timber has been a solution. But also has some ways made it a little more complex.
Exactly. That's right. That's where the complexity comes in.
But timber still has that advantage in that it serves the purpose. It looks good, it works well, and it really is bringing the whole thing together.
Oh, absolutely. I mean, that's a very good concern. I mean, you asked me the question. That's the whole purpose. You are building very sustainable building, will be carbon negative for many years, productive solution. Not to mention this geometry is very complex, so it took slightly longer than usual building. But again, comparing the complexity of the building, it's still a productive solution which used for this building. Therefore, I would say, I mean, you have a wonderful piece of structure in front of the Bedok Reservoir Road.
Right, great. Thanks.
All right, thank you, Ken.
Teddy.
Thank you.
Haywen, it's good to see you here on the site. So how did you get involved right at the beginning with this? Were you involved in the drawing stage and in the design stage?
My role in this project, I started off with the design for safety professional. So thereafter, the design architect for this building, she left the firm, and then I took on as the project architect together with the design for safety professional role.
So how important was it to work with Venturo, to work with the timber builders right from the beginning?
Yeah, correct. So from the beginning, when we conceptualize this, we need specialists like Venturo to come in to do the design so that we know this thing can work. So right from the start, when we were doing the express of interest for this project, we did engage with some other firms who became less interactive as time goes by. So at our last resort, we actually managed to find Venture, and they are very helpful to help us to conceptualize the whole thing and make sure that this whole thing can work before we go out for tender.
And the decision to use MET, mass engineered timber, was really a suggestion from BCA, or was it a requirement?
So BCA has this thing called MET funding. So they award projects with some funds in order to test out this material. And it's gaining popularity in Singapore because of the good properties of MET. You can achieve big spans, you can achieve very nice environment. When you walk into a building, you can smell timber. And it's very good for the space itself to have a timber finish. So when PA started out, they wanted to apply for this funding because it's an interesting material, and they put it in the brief under the EOI for us to actually design using this material. So what we came up with is, when we look at the context of Bedok Reservoir, we wanted a building that kind of comes up and goes down. So it needs to blend in with the landscape. And then because Bedok Reservoir has a lot of trees, a lot of mature trees, and unfortunately this building itself is sitting on a lot of old kaya trees. So we had to cut them all down. But of course, kaya itself has a problem. So NParks is okay for us to, cut down all the trees. And in replacement, we wanted to have a timber building to replicate this kind of biomimicry of having trees on site.
Right.
Yeah.
Okay, so you've constructed or brought the trees back in terms of the building. Great. So, and do you find working with timber or designing with timber in mind, there's some special qualities that timber has?
For this building, I wouldn't say so, but of course, it helps the space a lot. And of course, when we are doing these bold designs in portal frames, it looks very good. So if you were to imagine all these things in steel, it won't feel as warm, it won't feel as cozy, you won't even feel close to nature on this side. It will be so industrial looking. And we are just building another shed.
That's right.
So this building is really special, and of course the portal frames help to mimic soaring waves. This is like a crashing wave all the way. We soar cantilevers towards the front. Yeah, where we have a huge cantilever at the front as the end of the crashing wave.
And you're able to keep things very open. By having a big roof like this, so there'll be a lot of breezes, a lot of natural air moving around too.
That's one advantage of Bedok Reservoir. The wind here is so good that we wanted to keep things open. So we also designed this whole driveway, lobby site so that wind can just pass through the building.
And I understand that you've also built in, so there's like a green roof as well?
Correct.
Tell me about that.
So actually this green roof, we had put in a special material. It's actually called a pre-grown vegetation net, whereby it's only 6 cm, and this was recommended to us by NParks. So in an effort to, we wanted this whole thing, but to have a proper green roof, it will be too heavy. So at first we told NParks, look, we have no idea how to do this. We need to keep this light because of the design of this whole place. We can't have a heavy roof. So it's impossible to do a green roof. So they actually recommended us this material, whereby it's a pre-grown vegetation net of about 6 cm, and it's on a layer of fleece, and there are little plants planted on it, which they will never grow taller, nor they will die out. So we chose drought-resistant plants, and it was just laid onto the roof like a sheet of net. Yeah, so this helps the whole building blend in with the surrounding, and it looks really nice.
And will people be able to use the roof? There'll be areas where they can go up on the roof?
Yeah, you can just use any areas on the roof. So for this purpose, we wanted to join the jogging path up to the roof, so that people can, jog along the jogging path and have an option to come up to our site, go up the feature staircase, go all the way up to the roof, where they have a viewing platform. They can see the whole reservoir, then they can come down, continue their way on their jogging path. So this was one of the stronger concepts that we have from the start, where we won the project. So the client wanted to keep this so much. We actually tried to work the whole dynamic of the building to cater for this. And it's also BFA free, barrier free. So people on wheelchair, they can actually take the lift up here, go up the ramp, and also enjoy the whole roof.
So this will probably be the first building in Singapore to have a jogging track on the top of the building.
Maybe not, but that's our aspiration, and that's what we wanted to do.
Great. Okay, thanks very much. That's great. So tell me a bit about how you worked with the architects from the beginning, because that obviously seems to be the ideal way to do it. Did it happen here?
Yeah, absolutely. There's actually a bit of history that I want to share with you about this project. This team of consultants, we have been working since the beginning of the conceptualization of this project. In fact, we actually won the competition for the design of this building, from concept to the overall design. And when the project was awarded to us, we started working together on the framework of the building. So to answer your question, yes, we have been working together with, not only with the architect, but the other members of the consultant team, like the mechanical, electrical engineer. Yeah, so it's a collaborative effort that we have put in for this project. Yeah, we are not working autonomously.
No.
We're working together as a team.
Right.
Yeah.
And were there any particular challenges working with timber, with mass engineered timber? Did this present any particular engineering problems?
Oh yeah, absolutely. Because the material itself is not very common in Singapore. So I think this project is one of the pioneer projects in Singapore that use timber as the main structural element.
Yeah.
So that in itself presents a lot of challenges, both technically and practically. When it comes to the technical calculations and all that, the timber code in Singapore, which we have just recently adopted Eurocode, is fairly new. So there are other provisions that may not be completely applicable to the country and to the exposure that we have here in Singapore, where first and foremost it's a very humid country.
Yeah.
So that will have to come in play very significantly when it comes to design. So upon installation, yeah, you also see a bit of challenges because timber naturally can absorb a lot of moisture from humidity, from rain, from weather. So the challenge is to always protect the timber element from exposure to weather, so that it doesn't absorb too much moisture and eventually deteriorate. Yeah, so we have to put up very rigid and detailed standard operating procedure on how the materials will be delivered to site and how we will protect them, how it's installed. Yeah, so every step of the way is closely monitored and making sure that we're doing it properly.
And even though the timbers come from Europe, from a very different climatic situation, it does seem to fit into the tropics all right.
Yeah. I mean, there are not only Singapore, but there are places within the tropics region that actually uses timber as the main structural element. Although in Southeast Asia, generally we are mostly having hardwood here. Our rainforests are made of hardwood, but that being said, it's not a very suitable material for timber, structures like this, because it's not sustainable, because hardwood, as you know, grow over thousands or even millions of years before they mature. So when you chop down a hardwood, that's many years lost.
Is this the first time you've worked with timber on such a big scale for the structure of a building?
In Singapore, yeah. It is our even my company. This is our pioneer project, using mass engineered timber as the main structural element for the building. Because usually in Singapore it's reinforced concrete, and reinforced concrete comes with a host of different types, and you have structural steel. So these two are the most common types of materials being used in Singapore construction industry. So engineered timber is quite new, and we're lucky and fortunate to be able to do this project as our pioneer timber project.
Because it certainly seems to be a trend from everything I read, and in some cases write about, the trend towards mass engineered timber. It's starting to take off for tall buildings, for big buildings like this. So do you see this as something that Singapore would do more with timber?
Absolutely, yeah. I think there's a future to the mass engineered timber being used as the main structural element. But there are also a host of challenges.
Of course.
For instance, the supply and the logistics of the delivery from as far as Europe to all the way to Southeast Asia. So that in itself is a challenge. Because just like what happened in this project, in the midst of COVID-19 pandemic, we had problems with the deliveries, the schedules being delayed and all that. So the availability of material, the deliveries, and also how you keep them well protected with the moisture. Because this country is a very humid country.
Of course. And I suppose one thing that I certainly have read, that timber has a very because you're storing carbon in the structure, unlike concrete and steel, which have a lot of embedded carbon, that isn't an advantage, it's a disadvantage. So timber we're certainly seeing as the material for the future, with less carbon, zero or net zero
carbon emission
contribution. So that seems to be an advantage. And in terms of working with it from an engineering standpoint, because it's called mass engineered timber, this must be an advantage in some way, but you just need to do more of it. You need to have more examples of it.
I mean, in terms of the basic engineering principles, the calculations are pretty much the same. It's just that it's a different material. So there are certain factors that you need to consider when designing it. But in terms of the fundamentals of structural engineering, it's pretty much the same with the other materials such as concrete or structural steel.
Right. So to put it colloquially, it carries its own weight.
Yeah.
It's strong, sturdy, but it also looks good.
Yes, it looks good, absolutely. And I think that it gives that cooling effect that is very pleasing in your eyes. And it makes you feel one with nature, I think.
Yeah, that's good. Okay, thanks very much. So tell me a little bit about what it's like working with wood and working with MET.
Okay, well, the first one is the MET, right? The wood structure. We can improve the buildability and DFMA things. Okay. Basically, in Singapore, concrete is a dominant construction material. But the concrete, always we face the challenges of temporary work. When we have the big elements like this, we want a lot of temporary work, temporary property and so on, right? So that's when I really can talk about a lot of time to do all these one. The second is safety. So they had to take care of all safety concern as well. Also, they want a big lifting facility as well. But this wood is a good thing, is very light.
Yes.
It's only 20% of the concrete weight. So even big members we can easily handle by using a small lorry crane and so on. Or even small member can be carried by 4 workers.
So it's light, but it's also strong. So it does what it has to do.
Yes, right.
Okay.
So that's a good thing. It's a good structure. Steel, steel is good, but problem is in the site construction you need a lot of skills. You see, if there are any changes, you have to bring back to the factory and you have to do the railing and so on. But wood, you can just use a normal carpentry member tools to cut or show, or you can drill, everything you can do it. So simple structures, wood is good options. We can do the changes at the site easily.
And it should mean less work on site, shouldn't it? So in principle that works. With this one, any particular problems associated with this project?
Okay, this project, if you look at the geometry, right? This is very different geometry. Normally we work with the regular building, rectangular or even circular building, but it's not slanting. But here our main challenge is slanting. You can see the columns are slanting, right? Yes. So we have to make a frame with a slanting column. Also it's leaning one side, it's not straight. So in the one frame itself is not stable. So we have to find the way to stabilize when you install it. That's the main challenge. So permanently, if you look at now, it's okay. What problem is when I install it, I had to install like this. It's not like this. Okay, normally you can install cylinder, but now I had to install like this because the frame itself is leaning. So we have faced a lot of challenges how to hoist this one and position in the side. So we project some temporary bracing and so on. We work on the temporary structures, how to stabilize in the temporary state. So that's a big challenge at this time, this project.
Okay, but the timber has worked, but it just adds some complexities to the construction.
Yeah.
Okay. And then here, of course, we are using some concrete. We're using some steel as well.
Yeah.
But timber is the predominant material.
Yeah.
And that works quite well as far as you're concerned?
Yes, right. It's quite well because still only we use a very light element, roof, right? Okay. So the major steel, timber, that's to say, if I use a concrete example, right? I want a pretty big temporary works and so on to construct this one. So it takes a lot of time. But here, I think they finish constructions and the installation is affected by COVID. But other than that, they may finish within 8 to 10 weeks.
Certainly timber is good to look at, and if it serves the purpose in terms of maintaining the structure of the building and it can look good. What are the other qualities that timber has from your point of view as an engineer?
Engineer point of view, okay. So, someone say it's maintenance, we need a lot of maintenance, but compared to steel structures, actually we don't need a lot of maintenance. In steel structure, every 3 years you can inspect it. So you have to do the painting, if you are rushing, you are remove and painting. But timber, just wash it is enough, the surface, you wash it enough. Some always mention it, concrete is almost maintenance free. But concrete also sometimes is cracked, then you got to cover extensive maintenance. But timber, we have to do the regular maintenance, but no need to extensive maintenance. That's a good thing about structure.
Okay, great. Okay, thanks very much. Tell me how this compares with some of your other projects that you've done in Singapore. How different is it?
I mean, obviously, when we look at the building, the level of complexity is unbelievable. I mean, what is interesting with this type of building is that, you know, we spend a lot of time in Singapore talking about productivity, talking about design for manufacture and assembly, which is basically how to rationalize the building process so that there can be more use of, say, connections and components and so on. But sometimes, you know, there's buildings that don't fit in that genre, you know, and you look at this building, it couldn't be any more unique.
Yeah.
I don't think there's another building in the world that looks the same as this.
Right.
So, you know, when you're making those sorts of statements, then I think it's really important that the material can work in a way that can create unique forms. So, you know, one of the key attributes of mass engineered timbers, of course, primarily it's very sustainable and it's productive, but it does have the ability to be able to build very unique forms. And you know, although a lot of engineering challenges, of course, we're looking at off-axis and cantilevers and all sorts of techniques to brace, special concealed connections and so forth. But the way that timber works, it's quite an intuitive material. And even when we take a building of this complexity, you know, timber is still a great choice. Particularly as, you know, remember these days we work a lot in 3D.
Right.
Can you imagine building this building
without
3D?
That's right.
You would have a shock of your life. So, you know, and again, because timber works so well with the BIM, with 3D modeling, and that modeling process eventually drives machines in the factory.
Yes.
So if you were building this with steel, eventually you'd have guys looking at programs, trying to manually weld connections and so forth. So a lot of the components, there's still quite a lot of standardization, I would say, in some of the approaches that we have. But I think, you know, again, it comes down to timber and it comes down to advanced modeling and digital construction. So
but I mean, to me, it goes to prove that timber can suit many different purposes and functions.
It can, you know, I mean, and again, it's always very much about the place, the proposition, and the time, you know. So, you know, it works great for these kinds of buildings, but, you know, would it necessarily be the best choice for something more generic? You know, I don't know, but I think certainly with this kind of unique building, I don't think you can think of any other product that would really do the job like timber. So that's great. I mean, with this type of building, you can imagine the upfront time was intense. This building was called on a performance basis, so it was very much up to the specialist and the specialist engineers and the manufacturers of certain components to come up with the best solution. Quite often we see there's two ways of building these buildings. There's that performance-based, where the specialists get together and they draw on all their knowledge and they create the best scheme. But another approach is when an engineer comes up with a solution on his own, which can be largely theoretical. So this is a prime, I would say, example of where that confluence of knowledge from different fields, from practicality of building, which is us, experience of engineers on previous jobs, and obviously the partners who have to produce products and machine products and create products. So I think that is a really important process, especially in a job of this complexity. In terms of time, obviously early engagement is everything.
Sure.
I mean, you can't imagine how many U-turns that they went through in terms of coming up with the right geometry, the right connection strategy. In fact, if we look at the top here, we'll see there's a connection where those two main members come together.
Okay.
You'll see here. Now that's using a new type of connection, which is called the glued-in rod.
Right.
So we've actually pioneered that in Singapore, and we've had to do full-scale testing to prove it. So there's been a great deal of preparation that's gone into to making this work. Yeah.
Okay. What you've learned on this particular project that might be different from others you've worked with?
For this individual projects that we have been working on, we have quite a bit of this geometrical challenge that are all different components and different size. And basically, a lot of those logistic movements that it has been really constrained towards this environment.
Okay, and how is it different from, say, the Jurong Lakes project, which you're also working on at the same time? What are the different challenges with this one?
For Jurong Lake, it's quite straightforward, where we do not have such a big components, whereby the frames over here, it's we pre-assemble the frame, we leave it as one.
So, have you got anything to add to that? Any of the differences or the challenges that you've found with this particular project?
Yes, actually, we at Ventura, we've had the pleasure of building in several forms of MET. I mean, in general, we can start with the general post and beam. Straight columns with a beam across, and that forms the structure. Now those are straightforward, and we are glad that we had our start off in MET buildings in that area, where it's a simple build, and our labor force, the operations team, they had a good time to understand timber in the building process. We moved on from there to using CLT structures, the CLT walling as the structure. And that also gave our team an extensive learning curve, moving from there. Now we move on to this structure here in Bedok Reservoir, which is going to be used as a water sports center here. And in this form, it's a geometrical challenge. We have 25 frames here, some as high as 12 meters high, all of them heavy components in the 11, 13 ton category. And every one of these frames, inverted U's, everyone is different. Every component is different because of the geometric shape. So with that comes the problem of logistics. For logistics, it starts from the production facility, which immediately, if you compare producing a column out of timber, compare it to a concrete prefabricated column, you can see the quick difference would be you are making a block out of timber and using a computer to cut out the shape, and it's done. Compared to a concrete structure, you have to make the formwork for the concrete and then remake another formwork for the next component, or rather alter the formwork. So it's a quicker process in the production line overseas. When it gets to us now, our big concern as operation team here is to ensure logistics moves correctly. The components are huge, we have restricted space on site, like in many Singapore projects. So the amount of material you bring on site and the sequence in which you stack them is very, very important to productivity, right? So there comes a whole learning curve for us to be detailed about our logistics, and we have learned. we take every opportunity we can to learn, and we are getting better as time goes on.
Sure.
Right?
So I suppose what it also proves, and maybe you can answer this one, it proves that timber in essence is very flexible. It can fit different situations. It might take a little bit more work to do that, but it seems to fit different situations very well, and we need to make more use of that maybe. Test the envelope a little bit, push things a little bit further. Any thoughts on that?
I don't really have any thoughts on that.
So, I mean, you've worked with timber for a while now. Do you feel there's an advantage that timber has?
The advantage of timber compared to steel, as in among the components, it's a lot lighter compared to steel.
Okay.
And in terms of like, we don't require, none of the hot work is needed at all to reduce all this resource.
So I understand this is the first time you've worked with mass engineered timber for a project. So tell us a little bit about your experience, how you found it.
We find it very different from conventional, especially in terms of material, the storage, the coordination among the different services, and the integration of the structure is so very different from our conventional method.
And you also had the complication of working through the whole coronavirus pandemic period. Was that additional challenges as well you had to deal with?
Of course, especially when the workers are not allowed to cross each other. So it has to be in a very sequential method, one at a time. So time actually lengthen the process.
Okay. So normally with mass engineered timber, there's less labor required on site, but this one has been a bit more complex. So has this still required quite to manage that process, to manage the logistics, been extra demanding?
Yes, I think because of the irregular structure shape, we actually manage it by using big cranes. Cranes, the logistics has to be very accurate to cater for the needs.
And what have you learned from this one, being your first project with mass engineered timber? How do you feel about using MAT?
Being the first project, we hope to have more such building coming up in Singapore. Especially in Singapore weather. I hope to see more such building.
So what are the advantages you see using MET? Even though this is complex, what are the advantages to you?
Less so-called less debris on site. We actually go off, deleted the formwork, the concrete, the plastering. So actually the site more clean. The site is cleaner during the construction.
And it looks good as well. Do you get some satisfaction from seeing the end result?
Yes.
Okay. Great. That's good. So is this the experience, or is this the trend you see in other parts of the world as well, where women are playing a more important role in the construction industry?
Yes, definitely. I mean, women can showcase a lot of things now, not only in construction industry, but also in other industry. I mean, being part of this construction where we can showcase what we can do and we can contribute more in the society, and building this kind of remarkable constructions is really a good feeling for us.
Because I see, and I've met many women who are architects, engineers, people working in the industry. So this has been quite a recent trend. I'd say the last 10 years, we've seen quite a remarkable shift.
Yes, an increase of contributions of women.
Okay, and this is happening internationally as well. I think you appreciate this, that you're seeing it in other parts of the world.
Actually, I think nowadays, as Joey mentioned, I mean, the world is more open to don't classify some jobs, especially for women. But nowadays we are moving towards a future where the women are also having very important roles within, not only to be the mothers, but also to have like a high jobs, like very important jobs. And I mean, it's very nice to see that change. Like now the generations are more open, not to always put the woman as a weak person or as a, no, I mean, nowadays we are trying to move to teach the generations to be more aware of this, that everybody has the equal rights and everybody has the same capacities, same qualities to do the same jobs as any other person. I mean, not only for a guy's job like before. So I'm very pleased to see these generations are trying to move forward, and of course it's also good for the society. I mean, it's good for everybody, because then we can try to make a better world, not only from the man's side, but also from the woman. And as Joy also mentioned before, like also the woman try to put a different touch. I mean, maybe when in a construction site, for example, there is a lot of guys, right? You are dealing with workers, with engineers. So when the woman comes in, maybe the tone can change a little bit, and it helps also to maintain an open communication, because it's different maybe from a man to man to a woman to man. I mean, maybe the communication could improve in certain way. So it's a nice thing to see.
And I think both of you are working with timber now as the predominant material. How do you find this? Is this something that you have appreciated for some time? You enjoy working with wood?
Yeah, definitely, because as what we are saying, timber is sustainable materials. We are pushing this in order to have a friendly materials in construction. So it's really a good feeling that we are constructing something that is friendly to environment, and at the same time it gives us a different twist, unlike the conventional method in construction. So seeing this kind of buildings is really something that is different and refreshing. Yeah.
And I think as women, I'm sure you appreciate too, you're more sensitive to perhaps the environment, but you're also more sensitive to people's health, the benefits that come from being in a wooden building, which go beyond just the aesthetics to being a healthier building, to better for people. Is this your understanding as well?
Yes, I think, well, because women, we have a different sensibility. Of course, it's like we care a bit, because we might carry child or we might not, but somehow we have it in us for protecting the environment. We have that maternity side, right? Always. So I think it's important also that we take care of the earth. I mean, I am very happy to work in this company, because of course it's not only for myself or for the rest of my colleagues, but it's also be responsible with the society. What are we going to leave to the other generations? So these buildings like this that have a sustainability behind is something that we can also try to teach the other people or the society on how we can build more sustainable and bring better life onto this city, right? And then Singapore is a very sustainable city. So also here they are very aware, and the government is also helping to achieve that way, to make it a green city, right? So it's good, it's an example to set as an example to other countries, how they are doing it here in Singapore. So I'm very proud to work here, and I'm very proud to work for Venturer, because at least we can leave something behind. It's not just only the job normal that you do, but you are doing the extra thing that is being sustainable and being social responsible with the nature.
So maybe you can tell us also how a building like this for the People's Association emphasizes the importance of responsible sourcing of timber, using PFC certified timber, using source map to show the tracking and tracing. How important is that to you?
Yes, actually now we are doing a source map. Venturer is also doing a source map together with the PFC certification. So this is going to be the first project for People's Association to be source map. And actually the source map is a very interesting thing. Maybe not many people know about it, but is a platform that helps you to identify where the materials come from, and they teach you to trace, to be exactly to find the places where the material came from your project. So it's a very interesting project. It's something very nice, and I think people also, we are going to be able we are going to embed on the project. If people have more questions about this, we can have some links after we finish the video to share with you and to share with other people to take a look about this source map thing.
So when the public come to use this facility, they'll be able to see that story of the source of the timber from Austria to Singapore, how it's been responsibly sourced and sent to Singapore.
Yes, we are building together, working with People's Association also on that, on developing a little bit of more information to be able to teach the people about being responsible on sustainable forest and being responsible on buying material and all of this. So that will help also to show to the people.
Great.
Particularly looking at Bedok Reservoir project, as we discussed with Chetty and Kevin and others, there were particular challenges with that, both in terms of the site and the design. But it was, everyone told me how difficult it was, because every piece of timber was different in terms of its shape and size. So that made it more difficult in terms of the construction. So was that a factor? Were you involved? You were involved from the beginning in designing that?
I think in this kind of buildings where you have a complex geometry, it's always a balancing act between all the architecture constraints and the way you want the structure to be integrated in the architecture. So we could make things a bit more rational, but then we would have missed some clearance height, clearance width, the maximum height of the buildings, some of the concern about the interfaces, and all this component actually affects the way you actually build the geometry of the structure. So these are the parts where actually we're taking into account in the way we generate the geometry and the way we want to achieve a structure which looks seamless in the way it integrates in the overall experience of the architecture.
And certainly, I mean, it was a very impressive structure. And again, minimizing the use of concrete, and I think there must have been some metal steel in the building, but very little. I think it was concrete. The end walls, I seem to recall, they were concrete walls?
So there were some RC shear walls
at
the end of the buildings. And then some of the bracing were actually in CLT walls. In some of the parts of where we have this curved part where we have very tight radii, we actually have some steel pieces hidden in the timber.
But it certainly was a very impressive structure, and this is where, from looking at a number of Ventures projects today, timber seems to work best when you've got a big structure and you can emphasize and show the timber at its best, which certainly you did there.
So basically agree that was the kind of complexity in the way the structure was defined. But as you can see, actually we had the limitation of the height of the building. I think it was related to the access of the firemen to the top of the structure. And then we had all these different clearances, whereas it's clear height below the rafters, because you have a first floor here, a second floor here. Whereas it's the clearance, the clearance width between the column and the interior walls, whereas the interface clearance for the detailing above the roof structure. So all these tiny things which are completely unrelated to the way you build the geometry actually affect the way you build the geometry, because you, at the end of the day, what you want to achieve is a structure which actually looks like smooth, especially in this type of geometry, basically.
We wanted to achieve the look, the shape, and a lovely flow, which the timber suits as well. It's interesting too to see how it's being used, and I was impressed when people from the People's Association were telling me that people can actually effectively jog through the building. So it becomes a jogging track, which I think is probably the only one in Singapore where you can literally go up a ramp or up some steps into a building and run along a corridor or a passageway and come out the other end.
So I think from early stage we knew that basically the building was a kind of open structures, and the top of the roof is actually accessible, so which actually give us a bit of trouble on the way we marry the detailing of how we attach the ramp on the top of the roof to the actual main structure. So yeah, in a way it's a constraint we have taken into account from early stage.
One of the challenge we face, Sophie, is that mainly, I would repeat this again, it's the geometry. The architect circle, they have come out with a very wonderful design. They won the competition because of this design, and then we actually wanted to make that design happen. But Sophie, myself, Ronnie and co, we were all scratching our head day and night to understand how this thing could happen. Because we don't want to change anything where the architect will have the impact on her design, and we wanted to actually make that design into a reality, right? So just correct me if I'm wrong. So we had a number of challenges in terms of introducing bracing, converting some of the timber base into concrete, but most importantly, we managed to keep the original design intention. Yeah.
Yes, exactly, Chetty. Exactly. I think the intent was kept while reaching all the performance the architect was asking for, and this is quite a feat for this type of shape of building.
Yes, you mentioned the bracing. So you pointed that out when I was there, Chetty, that some of the big beams, because they were effectively, if I get it right, they were leaning out. Yeah. They needed additional bracing. Okay. But it's a very impressive building, but it looks good and it feels good, which is, I think, the main requirement. And certainly looks good across the water as well when we were filming and getting photos.
Yeah, and then again, that's the very first project in Singapore to use this very efficient concealed connectors known as gyroids. We use that to keep the timber members relatively smaller compared with traditional steel plate connections with doubles. So that's also a very proud thing that we did, that we introduced this new technology into Singapore for the first time.
Actually, it's not the first time, Chetty, you remember, but it was the first time in such...
Yeah, it was the first time, that's right, it was in the first time in this kind of relatively big scale. where you have a lot of loads. I mean, we did minor, like small projects with gyro connectors, but this is like talking about in load wise, it's really high, right?
It is. So Chetty, you are right to talk about this, because I think because it was new and things was relatively new, and it was a key component of the building structure. We actually went through a lot of rounds with RNK and yourself of presenting this type of connection to BCA and to convincing them this is actually working. So gyro, it's a connection, it's actually quite widely used in Europe, that like 20 years of history of using this type of connection, mainly in Germany. But basically to convincing BCA that this was actually workable, and in the specific condition of Bedok water venture where we have all those columns exposed, it was a kind of non-linear process actually to find the right connection with the right component.
Exactly. So we can I think talk for many hours about the challenges of this project, because it's very challenging how we deliver this. Yeah, I mean, the next thing is again the fire. In terms of the fire, as Sophie mentioned earlier, that we had to design the structure for 1 hour fire rating based on the charring method. So we kept all the components exposed. But again, there is no timber on the facade itself as a facade element. These are using different components such as non-combustible materials. Again, as you mentioned, if you use timber in the facade line in Singapore, a regulatory requirement that need to be protected with deluge systems, like the pressurized sprinkler systems. So we avoid that. We had a frame, but the frame is fine because it's considered as a column. However, it's not considered as a facade wall. So we avoid that, and we introduce certain elements such as GFRC, which are non-combustible, and we still meet the requirement of the architect's intention.